Welcome to today's presentation on programming paradigms. In this section, we will explore the core concepts of programming paradigms and their impact on software development. Programming paradigms refer to the different approaches or styles of programming. They shape the way we solve problems and structure code. Understanding these paradigms is essential because they help us choose the right approach for a given task, improving both productivity and maintainability. Let's dive into the key paradigms in programming. There are five main paradigms we will cover today: procedural, object oriented, functional, logic, and concurrent programming. Each of these paradigms offer unique ways to approach problem solving, and we will look at each of them in more detail shortly. Procedural programming is one of the oldest paradigms, focusing on a sequence of instructions or steps to solve a problem. It's centered around functions or procedures that process data, often using loops and conditionals. Popular languages like C, Pascal, and Fortran use this approach. A classic example is calculating a factorial through a series of procedural steps. Object-oriented programming, or OOP, is based on modeling real-world entities as objects with properties and behaviors. The key principles of OOP are encapsulation, inheritance, polymorphism, and abstraction. Languages like Java, C++, and Python use OOP. A great example is a class hierarchy where a vehicle can be subclassed into cars, trucks, or electric vehicles. Functional programming treats computation as the evolution of mathematical functions, avoiding changing state or mutable data. It's built around functions that take inputs and produce outputs without side effects. This paradigm emphasizes immutability, first-class functions, and pure functions. Languages like languages such as Haskell, Scala, and Python support functional programming. We often see examples like map and reduce being used to manipulate data. Logic programming is a paradigm based on formal logic. It uses facts, rules, and queries to solve problems. Instead of specifying how to solve a problem, you define relationships and let the system infer the solution. Prolog is the most well-known language for this paradigm. For example, you might define relationships like father, John, Mary, and ask queries such as who is the father of Mary. Concurrent programming focuses on managing multiple tasks simultaneously. This paradigm is crucial for real-time systems, multi-core processors, and handling multiple users. Concurrency involves synchronizing threads or tasks to avoid conflicts and ensure smooth execution. Languages like Java, Python, and Go provide features for concurrency such as threads and coroutines. Each paradigm has its strengths depending on the task at hand. Procedural programming works well for straightforward, sequential tasks. OOP excels in scenarios requiring complex systems of interacting entities. Functional programming is ideal for tasks requiring immutability and mathematical computations. Logic programming is best suited for tasks involving reasoning, while concurrent programming is essential for real-time and multi-threaded applications. Let's consider the example of building a simple calculator in different paradigms. In procedural programming, we would write a sequence of steps for each calculation. In OOP, we could define classes for functions, for numbers and operations. In functional programming, we might use functions like map or reduce. In logic programming, we would define rules for operations and query the system for results. Finally, in concurrent programming, we could handle multiple calculations at once using threads. To conclude, each programming paradigm has its own strengths and ideal use cases. Understanding these paradigms allow developers to choose the right tool for the task, improving efficiency and software quality. Whether you are working with simple scripts or complex systems, the right paradigm can make all the differences. That wraps up the presentation. I would now like to open the floor for any questions or further discussion. Feel free to ask about any of the paradigms or examples we have discussed today. Thank you for your time and attention. If you have any additional questions or need further clarification, don't hesitate to reach out. I appreciate your participation and hope you find this session informative.